In this video, we are going to discuss some very vital basics of vectors. For example, number one, we have to discuss definition of vector. Number two, direction angles, direction cosines, and direction ratios of a vector. Number three, unit vectors and concept of I cap, j cap, k cap. Number four, representation of a vector in terms of I cap, j cap, k cap. Number five, how to find a unit vector along a given vector. Number six, how to find a vector of a given magnitude in the direction of a given vector. Number seven, position vector of a point. And number eight, how to write a vector when the position vectors of its initial point and terminal point are given. So now let's start with definition of a vector. A physical quantity having magnitude and direction both is called a vector quantity. For example, displacement, velocity, force, acceleration, etc. Let a vector makes angles alpha, beta, and gamma with x-axis, y-axis, and z-axis respectively. Then alpha, beta, and gamma are called direction angles of the vector. Say this is x-axis, y-axis, and this is z-axis, and let OP is a vector in a space. So suppose it makes alpha angle with the x-axis and beta angle with the y-axis and gamma angle with z-axis. So these alpha, beta, gamma are called direction angles of the vector OP. Now, if alpha, beta, gamma are direction angles, then cos alpha, cos beta, and cos gamma are called direction cosines of the vector. Now, let us talk about direction ratios. So, if we divide or multiply direction cosines by any number, all the three direction cosines are multiplied or divided by any particular number, then the resulting numbers are said to be direction ratios because those numbers will be in the same proportion as that of direction cosines. So, for example, direction cosines, which are written in short D dot CS, are 1 upon under root 3 and 1 upon under root 3 and 1 upon under root 3. So if we multiply all these three direction cosines by under root 3, we get 1, 1, 1. The resulting number will be 1, 1, 1. So these 1, 1, 1 are direction ratios. And again, if we multiply all these three numbers by some other number like 2, so these numbers will become 2, comma 2, comma 2. These are still direction ratios as these are in the same proportion as that of direction cosines. So we may multiply these numbers again and again by the different numbers. The resulting numbers will be direction ratios and so on. So that means we may infer a very important corollary from this fact, that is, every vector has unique direction cosines, but its direction ratios are infinite. Now here we would like to discuss how to change direction ratios into direction cosines, because this is very important topic. So let A, B, C are direction ratios, which are written in short D dot RS. And generally direction ratios are denoted by small letters A, B, C, and direction cosines are denoted by small alphabets L, M, N. So L stands for cos alpha, M stands for cos beta, and N stands for cos gamma. So suppose ABC direction ratios are given and we need to find direction cosines. Then the way to convert direction ratios into direction cosines, simply we need to divide each and every direction ratio by square root of sum of squares of direction ratios. That means if each and every direction ratio is divided by under root a square plus b square plus c square, these direction ratios will turn out to be direction cosines. So if we divide a by this expression, that is under root a square plus b square plus c square, this is direction cosine L or cos alpha. And if we divide b by the same, it is second direction cosine, that is m or cos beta. And if we divide third direction ratio by the same expression, it turns out to be third direction cosine, that is n or cos gamma. So this is the way to change direction ratios into direction cosines. Now let us talk about unit vector. A vector whose magnitude is 1 is called a unit vector. And this unit vector may be in any direction, but if a unit vector is along x-axis, it is denoted by I cap. A unit vector along x-axis is denoted by I cap, and a unit vector along y-axis is denoted by j cap, and a unit vector along z-axis is denoted by k cap. Vector in red color is a vector along x-axis, and if its magnitude, or we may say its length, is 1 unit, it is denoted by I cap. A unit vector along x-axis is denoted by I cap. Similarly, a unit vector along y-axis is denoted by j cap, and a unit vector along z-axis is denoted by k cap. Now here let us talk about vectors in terms of I cap, j cap, k cap. So let A is a vector and which has projections A1 on x-axis, A2 on y-axis, and A3 on z-axis. So the projection of a vector on x-axis means if suppose OAB is a vector, A is the initial point and B is the terminal point of the vector. So if we drop perpendiculars from A and B on x-axis, so suppose AL is a perpendicular from A on x-axis and BM is a perpendicular from B on x-axis, then the length intercepted between these 2 points, these two perpendiculars, is said to be projection of AB. Projection of AB vector on x-axis. In a simpler concept, you may consider projection of a vector as a shadow falling over x-axis if a lightning source is mounted above the vector AB. Similar is the concept of projection on y-axis. In this particular case, if suppose this projection is A1 and this projection is A2 and the projection on z-axis is A3, then vector A is given by vector A is equal to A1 I cap plus A2 j cap plus A3 k cap. Now, let us talk about how to find a unit vector along a given vector. A vector is a given vector and we need to find out a unit vector along vector A, which is denoted by A cap, is given by A cap is equal to vector A divided by magnitude of vector A. For example, vector A is a vector A1 I cap plus A2 j cap plus A3 k cap. So as we know well, magnitude of vector A is equal to under root A1 square plus A2 square plus A3 square. This is called magnitude of the vector, that is the length of the vector. And if we divide A by its magnitude, this is equal to a unit vector along A vector, that is A cap. So A cap is written as A1 I cap plus A2 j cap plus A3 k cap divided by under root A1 square plus A2 square plus A3 square. So this is a way to find a unit vector along a given vector. Let us take an example. Say a vector A is 2 I cap plus j cap minus 2 k cap. So we need to find out A cap, that is a unit vector along A vector, that is A cap, that is required. And as we know well that A cap is equal to vector A divided by magnitude of vector A. So ultimately we need to first find out the magnitude of vector A. So magnitude of vector A is equal to under root 2 square, that is the coefficient of I cap square, plus coefficient of j cap square, that is 1 square, plus coefficient of k cap square, which is minus 2, so minus 2 square. And if we simplify this, we get 4 plus 1 plus 4, which is equal to under root 9, which is equal to 3. So 3 is the magnitude of this vector, and if we divide this vector by its magnitude, it turns out to be a unit vector along itself. So A cap is equal to 2 I cap plus j cap plus minus 2 k cap divided by magnitude of A, that is 3. We may write it as 2 upon 3 I cap plus 1 upon 3 j cap minus 2 upon 3 k cap, because 3 is the common denominator, so it will divide each and every term in the numerator. So if we divide each and every term in the numerator by 3, we get 2 upon 3 I cap, 1 upon 3 j cap and minus 2 upon 3 k cap. So this is the unit vector along the given vector A. Next, we would like to discuss how to find a vector of a given magnitude and along a given vector. Suppose we need to find out a vector of magnitude lambda in the direction of a given vector, vector A. So this is given by lambda times unit vector along A vector, or lambda times vector A divided by magnitude of vector A. For example, the question is find a vector of magnitude 8 along a vector 3 cap minus 2 cap plus 4 cap. Then the required vector of magnitude 8 along this vector is given by 8 multiplied by 3 cap minus 2 cap plus 4 cap divided by under root 3 square plus minus 2 square plus 4 square, or 8 multiplied by 3 cap minus 2 cap plus 4 cap divided by under root 9 plus 4 plus 16. That is equal to 8 multiplied by 3 upon under root 29, as the sum of 16, 4 and 9 will be 29. So 3 upon this under root 29 will divide each and every term of this vector. So that will be written as 3 upon under root 29 I cap minus 2 upon under root 29 j cap plus 4 upon under root 29 k cap. Now open it up, this bracket. This 8 will multiply each and every term inside. So 8 3s are 24 upon under root 29 I cap minus 8 2s are 16 upon under root 29 j cap plus 8 4s are 32 upon under root 29 k cap. Now next point is position vector of a point. So let A be a point in space, then its position vector is the vector which joins the point A to the origin. That is, OA is the vector which joins a point A with the origin. So this is called position vector of the point. Suppose this is the x-axis and this is y-axis and this is z-axis, and A is a point in the space whose coordinates are x1, y1, z1. So the vector joins O and A is said to be position vector of A, which is denoted by OA vector, and that is given by OA is equal to x1 I cap plus y1 j cap plus z1 k cap. For example, A is a point whose coordinates are 1, 2, 3, and B is another point whose coordinates are 4, -1, 2, and C is a third point whose coordinates are given as 3, 2, -1. So the position vector of these 3 points, which will be represented by OA vector. OA vector is the position vector of this point, and that will be equal to 1 into I cap plus 2 into j cap plus 3 into k cap. OB is the position vector of point B. So since the coordinates are 4, minus 1, 2, its position vector will be 4 into I cap minus 1 into j cap, that is minus j cap, and 2 into k cap, that is 2k cap. Similarly, OC vector is the position vector of the point C, and its coordinates are 3, 2, minus 1, so its position vector will be written as 3 I cap plus 2 j cap minus k cap. So now let us talk about to write a vector AB whose terminal point is x2, y2, z2 and whose initial point is x1, y1, z1. So as we know well, the position vector of A is given by OA vector, which is equal to x1 I cap plus y1 j cap plus z1 k cap, and OB is the position vector of terminal point, that is x2, y2, z2. So its position vector will be x2 I cap plus y2 j cap plus z2 k cap. So suppose we need to find out vector AB, that will be equal to OB vector minus OA vector. Be careful, AB vector is always equal to position vector of its terminal point minus position vector of its initial point. So AB vector is equal to OB vector minus OA vector, and if we substitute the values of OB vector and OA vector in this relation, we have x2 I cap plus y2 j cap plus z2 k cap minus OA vector, which is x1 I cap plus y1 j cap plus z1 k cap. So if we simplify further, we may write it as x2 I cap, and together with x2 I cap we may write minus x1 I cap, which is obtained by this bracket. When we open up this bracket, this minus will change all the signs inside. So each and every term of this vector will be negative. Negative x1 I cap, negative y1 j cap, negative z1 k cap. And these components are grouped with these components. So x2 I cap, and we better write x1 I cap with this. So minus x1 I cap. Then plus y2 j cap, and we better write the minus y1 j cap. And finally, third component of the first vector, that is z2 k cap, and the minus z1 k cap is grouped with this term, that is minus z1 k cap. So if we take I cap common out of these two terms, we have x2 minus x1 I cap, plus if we take j cap common out of these two, within a bracket we have y2 minus y1 j cap, and out of these two terms, if we take k cap common, within a bracket we have z2 minus z1 k cap out. So in this way, we may find a vector whose terminal and initial points are given.